Hello and welcome to Code Red. I'm Kasper Borg Nissen, Director of Developer Relations at Zero and co-host of the Code Red podcast, where we explore platform engineering, observability, and the people shaping how modern software systems are built and operated. Today's episode is about platform engineering, AI, observability, and what happens when operational excellence, platform engineering, and AI start to converge. I'm excited to be joined by Rachael Wonnacott. Rachael is a platform engineering leader, a long-time advocate for cloud-native technologies, and someone who spent years helping large enterprises navigate the realities of platform adoption, operational excellence, and developer enablement at scale. Rachael, thank you so much for joining me.
Thank you so much for the invite. I'm flattered to be here.
Awesome. So, as you know, we have this traditional Code Red opener. So, what has been your biggest Code Red moment, an outage, an incident, or a hard lesson that fundamentally changed how you think about platforms or operations?
In my tenure, there have been quite a few, so this was difficult to choose. I've gone for something that I think ties into the importance of observability, so we can refer to it later. And this would be sort of 7 years ago when I was just an individual contributor during COVID, and we had built a platform on AWS that predated a lot of the services that we know today. And part of the complexity with that meant that we needed to build lots of our own custom resources as part of our Terraform providers. We couldn't take everything off the shelf, particularly for our network resources. And we learned the hard way that if you don't test your edge cases, that things might go down. And I'll give you some specifics. So on queue that day, which essentially is our operations rota, and I'm looking at the pipeline and all of our smoke tests are going off, and I'm thinking, what could this be? We've not made any major changes. And we realized that Terraform had recently been upgraded and changed the way that the null resources at the time behave. This has since been changed into Terraform data. So you won't get this problem yourself. And so much of the custom code that we had written in Python to try and mimic that Terraform behavior that wasn't yet in the provider didn't respond in the way that we thought it did. The long and short, we had some virtual interfaces in our networking that were then deleted unexpectedly.
Ooh.
But the resolution of this is two things. One, we had a really strong team that was pair programming. So I had a second pair of eyes on the call with me right as it happened. And also, we did everything from GitOps. So we were able to bring everything back up in under an hour. So no one even really noticed just how bad this outage could have been. A little bit of luck on our side that we were online at the time, but our smoke tests do go to PagerDuty. So we would have been called out immediately. So a little bit of observability early day thinking there for you.
Yeah, nice. And also, like, I guess platform engineering that you actually built the guardrails and all of that, so that you were actually able to recover from an incident like this, right?
Absolutely. I think much of my opinions that feel or perhaps seem polished now come from years of getting things wrong in my past. So lots of this is homegrown experience in learning and failing.
Awesome, man. Maybe we'll come into to more as we go ahead in this conversation. But I want to start with like topic number one, which is like platform engineering beyond the slide deck, because I think a lot of the platform engineering conversation today comes from vendors and consultants and conference talks in general, and also now we have like a maturity model. And you've spent years living this in a large organization. So when you compare what you sort of hear in the platform engineering conversations at conferences with the reality inside an enterprise, where do you sort of see the biggest sort of disconnect?
I think a lot of the theory is the same, but the realities of implementing those strategies don't always look as clean or as simple as a vendor wants to present them. And that isn't necessarily that the vendor is disingenuous. It's just that there are many other organizational challenges outside of the technology that might be causing you problems. And each particular company or organization will have its own flavor of those challenges. So often for me, I talk a lot about the socio-technical challenges of building a platform. You have different kinds of users. You might be hosting applications. You might be hosting agents. You might have API integrations. And how you build your platform is likely going to be very unique to the product, hopefully, if you're doing platform as a product that you want to build for your organization. So for me, in my 10 years, particularly at Fidelity International, the biggest challenge that we faced was that vendors often talk about one slice of the users that we're hosting. So our platform is essentially a container runtime if you want to be reductive in your argument. And it doesn't necessarily think about the complexity of a large scale enterprise that's going to have a maturity curve of users. So you might want to have more or less flexibility for your user. And to bring that into observability, because that's what we're here to talk about, you've got to think about how much you abstract away from the user so that they have a better developer experience. But equally, if something goes wrong, can they learn and understand what exactly changed under the hood so that they're able to address their code and hopefully improve their applications?
Yeah, now you also like hinted a little bit that the platform doesn't only have like one set of stakeholders, right? Can you maybe like go a little bit more into the details of the different stakeholders that you see and from your experience?
Absolutely. So, a little bit of context. Fidelity was doing what I would consider platform engineering long before we had a name for it. So, during that rise of DevOps, there was a company you might remember called Pivotal, who were the main contributors to the open source product Cloud Foundry. And we built ourselves a on-premises private cloud, I would say a long time before that was the trendy thing to do. And so many of our applications then were quite immature in their approach to 12 factor, and we learnt lots over that journey. Speed that up to more recently, because of the way the market has gone, without being too defamatory about any products, Kubernetes kind of won out here, right? And so we needed to build something more modern. By that time, we had public cloud, and so we wanted to host our container runtime on the cloud so that we could leverage some of the cloud provided services to reduce the cognitive load for the platform team as well as for the developers. And so we had two main user bodies. We had the applications that wanted to migrate to cloud, which were typically more complex by virtue of the fact they needed re-architecting to work well in an ephemeral environment like Kubernetes on the cloud, versus some of those more traditional Kubernetes applications like simple web apps. But I also think that data integrations and APIs are two things that we very commonly see wanting to run on Kubernetes.
Yeah, I recently had a Abby Bankser on this podcast as well, and one of the things that she mentioned was that like they will Syntesso see sort of platform engineering as this marketplace where you have producers and consumers, right? Is that also something that you have experience with from actual reality in an enterprise, that you have not only users consuming the platform but also other teams building components on the platforms that then is also exposed to other users of that platform?
Yes, absolutely. So, something that we always wanted to achieve was maximum self service and almost have a self fulfilling prophecy where the platform grew as a product by virtue of the application teams building some of that product for themselves because they were the domain specialists. I think that's the utopia. I don't know if it's the reality, and I can talk through a little bit about what I mean. Some users have much more discrete use cases, such that it is simply therefore more straightforward to build something using inner source. So we have an inner source community that's really vibrant. And the idea there is much like the open source community where you contribute back to the ecosystem. However, not all teams are incentivized to be as active in that contribution. So sometimes I think we see the shift slightly too much towards consumer and not enough towards producer. And much the same as in the open source community, if people lead the organization or there are changing business needs, maybe the team that originally built that module or that product in the marketplace, if they no longer need it, but other people are consuming it, who then takes over the
Yeah.
ownership and the maintenance? So we definitely do some pockets of this really well, but I think it would be egregious to say that we've done it perfectly in the utopia that I know Abby would like to see.
Yeah, I think from my perspective as well, I've also experienced a similar thing where it works pretty well until that team has other tasks to do or and stuff like that. And other priorities come in, and then maintaining a specific module is being down prioritized. It's an interesting concept, at least, to think about your platform as a marketplace with both producers and consumers. So we were talking about like vendors. We started out with the vendors, what the sort of the difference between what vendors see as platform engineering as and what you experience in reality. But where do you then think that vendors are like underestimating things? Are there any like certain areas where you see, okay, I see a lot of vendors doing this, but in reality, this is completely not how it is. This is something way harder than you make it sound like.
So I'll actually take a positive slant and give you an example where I think vendors have done it well to explain what it could look like and then give you some contrasting examples. So the axiom of my argument here is that not all vendors are thinking about the cohesion of their product with other products. And if you think about particularly Kubernetes, what Kubernetes in its vanilla form or even EKS as an example provides isn't really a platform, right? You've got the control plane and the data plane, but you still need to think about your CNI, your observability, and everything else that goes into making that truly a platform. So when you're building in an enterprise, typically you have lots of use cases to cater for. So the number of add-ons that you might be exploring tends to increase a lot quicker than you might be expecting. The impact of this on the platform team is the cognitive load, and that is worsened when the add-ons that you're looking at, or the vendor products, let's say, don't necessarily operate well together. Now, that isn't by design, but it could be by oversight. Why would you necessarily build a product that works well with your competitor? Do you know what your competitor is doing such that you could build something that works well with your competitor? So the positive example that I'll give that we've had a fantastic experience with is the cohesion of Kyverno with Cilium. And one of the reasons when we built our original proof of concept that we went with these two products is because they would work together. So I think I would challenge vendors a little bit if they came back and said that it would be a strategic disadvantage not to work well together. Because actually, if you're known for working well with some of the other core products from the CNCF, for me, that's another reason to think there's longevity there. We can strategically put our eggs in this basket and not worry about a huge migration down the line. Because I'm sure you know, enterprises do lots of migrations. And so we're often thinking about the longevity of that product. In terms of the commonality of where vendors go wrong, and this is just one example, in my opinion, it's when you think about the layers that are in a platform. So Daniel Bryan of Syntasso, I think, spoke about this at QCon, but we speak so much conversationally, it could well be in other presentations, about the 3 layers of the platform. He comes from a Java background, so he loves to talk in threes. And in the early days of platform engineering, people got really obsessed with the portal. And he and I were talking a lot about actually the orchestration layer is where you design the impact of your platform. And the portal is ultimately just what improves the visualization, the dashboarding, and the developer experience of the UX, not necessarily the developer experience of your automations behind the scenes. It's not to say portals aren't really important. They are, and they have loads of value to add. But I think I saw a lot of vendors focus mostly on either embellishing their portal, advertising the portal, and not really thinking about what was the cognitive load for an existing platform to integrate both the orchestration layer and the portal on top of their IaaS at the bottom.
Yeah, and I think a portal is basically isn't it just like one interface into the orchestration layer, right? You could have multiple different interfaces that interact with all your orchestration layer underneath, right? CLI, I guess MCP servers and agents that are now also utilizing the orchestration layer to do stuff on a platform. So moving on a little bit, you already touched up on sort of the concept of platform as a product, and in practice, I know again this is coming from sort of the theory of like this is the sort of utopia. Platform as a product has become this idea for platform engineering and a key thing in platform engineering. But is it hard to actually make this real in reality from your experience?
Difficult to say it was anything other than a challenging, particularly if anyone is listening who I've worked with. There are some competing trade-offs that make this difficult to do. So the first one is knowing what the minimum is in your minimum viable product, because you need something to iterate on to even get user feedback. And if you are a product, you want user feedback. So that's the first challenge. The second sliding scale of the trade-off is between standardization and speed or even enjoyment of the platform if you think about this through the developer lens. So if you take the enterprise consideration, one of the main reasons that enterprises are often thinking about building a platform is to do with the cluster sprawl of their environments, or the fact that 10 years ago when they started on DevOps, everyone did DevOps their own way. And now you have duplication of code or duplication of tools, or worse, several tools with licenses that all do the same thing. So the enterprise wants to achieve standardization via a platform. But to standardize, you have to look for a common denominator. And that often then takes away customization from the developer, which can affect both speed and the experience that they're looking to achieve. So, as a product owner, you've kind of got two very different stakeholders who might disagree with you on what product looks like. So, the enterprise wants you to aggressively standardize, have predictable costs, whereas the developer wants you to be endlessly customizable. And I think you would struggle to find anyone in our sphere that would recommend being endlessly customizable. And I think that's why the marketplace element softens the blow when the platform team as itself can no longer expand the product beyond the cognitive load that they're capable of looking after.
Yeah, that makes sense. That makes sense. You mentioned earlier that you did platform engineering before platform engineering was kind of like defined as a term, right? And that would also mean that you probably also did, or at least to some extent, had an existing platform that you then need to slice and dice in some way into platform products. Can you talk a little bit into that process of how do you define sort of the capabilities? What is a product? How big is a product?
Yeah, absolutely. So the reason I claim we were doing it before it was platform engineering is from that specific era where PaaSes were popular. So platform as a service. Platform is in the name, so I'm sure you can see that. But there is a little bit of nuance around what a PaaS is versus what a completely self-service platform product is that I think often people that are further away from the work don't necessarily see. So one of the challenges we had with slicing and dicing our product, to answer your question, is that people assumed that Cloud Foundry and Kubernetes were like for like because they were both platforms. But actually, Kubernetes out of the box is not a PaaS. And if you were really to boil it down, it's just running your container and scaling and making decisions about whether to vertically scale or horizontally scale, depending on what you've, put the config into your platform. Whereas Cloud Foundry was a bit of ahead of its time in that sense, much like Heroku, where you had services that were off the shelf, and you could consider that a product boundary. So when we did our migration, we knew and had to expect that many of the service requests that we would get would be looking to replicate the experience that people had had on the Cloud Foundry platform. And so we needed to be careful to, one, make sure that we didn't make the move too challenging for them. But equally, if we're going to completely recreate Cloud Foundry in Kubernetes, why are we doing the migration? So we also
Yeah.
need to think about how did you bring us into the new era? And for me, what Kubernetes did particularly well, and will go on to do very well for us, is around AI and actually that scaling being really good for bursty workloads that you're likely to see with AI. And similarly, a lot of the work that we did using things, we looked at vCluster as well. So a little shout out to vCluster. A lot of the delineation of workloads and protecting workloads in terms of resource or computation competition across different workloads. You can't slice a GPU yet, so we haven't completely solved that problem. But I think Kubernetes handles data intensive workloads significantly better than the experience we have with both Cloud Foundry and Heroku.
Yeah, I think the early term was CAS, right? Container as a service, and I think I completely agree with that. That Kubernetes came with a lot of raw power, and it was not like comparable to what was defined as a PaaS back then. That was something in between like infrastructure as a service and a real PaaS. I think you already touched a little bit upon sort of now that you have a platform product in place. How do you then measure the success of that product? What kind of metrics are important in actually understanding whether or not your investment in both going into platform engineering, but also creating and running your platform components as a product is actually successful?
I think this is really hard to do. And so I would have some level of skepticism towards anyone that thinks they've done this completely or sufficiently. So there's always improvements. And part of this is to do with some of the more socio-technical benefits that are slightly intangible versus the mercenary view of what the business cares about. So if we remember that we all work for an organization and we're here to deliver essentially profit, the one metric that's hardest, I think, to show end to end, but would be most powerful is how much extra money are you generating via your new feature? And then if you think about that as a tree of things that feed into that, it's how quickly are you delivering features? How reliable are those features? Monitoring your incidents or the reliability of your platform. We also like to look at things like onboarding time. So one of our main focuses was how is it for a developer A to onboard to the platform, but also how quickly can they deliver their first feature? Is it friendly for juniors as well as for experienced engineers? That's a good signal for whether your abstractions are simplified enough. But equally, looking at whether we're enabling or stifling innovation. And this is really difficult because it's very personal and opinion. You want to make sure that your super users on in a golden cage. We talk a lot about building golden paths, but in an enterprise, when you're really heavily going after standardization, that can end up looking like a golden cage. And so I really like, I think this is another Daniel Bryant quote. So shout out to Daniel, was the golden bricks from KubeCon Salt Lake City 2024, talking about actually how do you have those composable pieces of your platform such that people are still doing the right thing, but they're not stuck in a cage. And for me, because we have such a diversity of both engineering experience, talent, requirements, business users, etc., trying to find a common denominator, be that lowest or highest, is still very difficult to do.
Yeah, I think, yeah, shout out to Daniel Bryan, definitely. But one thing that I actually spoke with him about, and also Abby Banks about, is like how small is a platform product if you're talking about bricks, because in many cases you probably have multiple stakeholders that you could use or reuse some of those bricks and stitch them together or in different ways, tailoring to specific users. What's your perspective on like the size of a
Mm.
brick in this case, and is a brick equal to a platform product?
This reminds me a lot of my theory of knowledge in the International Baccalaureate, where we ask, is the banana skin a banana or is it just a banana skin? Any of the Europeans out there, I hope you experienced a similar conversation. For me, I think I would blur the boundary deliberately and treat it almost like a Venn diagram, and I would have inheritance. So you would have the overarching product that can be comprised of individual products, but equally those services or products themselves would have a boundary that would make them a product. And I'll explain how I mean. So Kubernetes typically gets conflated with platform and hence the overarching product. And so that positioned my Kubernetes platform team as that boundary. So anything that we built or looked after was de facto considered part of that product. But actually, to talk about your question and the single unit measurement, if you look at that, we individually treated each of our services or our add ons typically as separate products. And the reason for that wasn't philosophical, it was due to logistics of maintenance. So we, wherever possible, were using open source components because we like the diversity of thought from the community. And also, you get more pressure testing when everyone's using a component. And so we would need to think about the product life cycle of the component that we were using. So while I wouldn't go as far as saying that we had a dedicated engineer or a product owner, we did apply, the best practices of operations to each add-on almost as if it were a product. So that would be one answer. The second answer, more specifically to the marketplace, is any component, service, or add on that was built outside of the platform team that we simply integrated but didn't manage the end to end life cycle of upgrades or, uh, patching, so CVEs or whatever else you were doing, if that was owned by a different team, while it would be a subset of the broader product, it also needed to be treated like a product in its own right. And if you've got products, you need roadmaps and you need to have communication with the relevant stakeholders of what the future is expected to look like as well.
Yeah, that makes sense. We've touched a little bit upon observability also, and now that we are on the topic of product, how do you see observability? Is observability a product in the platform that you're coming from?
So this is a really difficult question to answer because I haven't fully settled on where we sit, and I'll explain why. So something that I think you even mentioned in your recent conference presentations is There's observability of the platform itself, but there's also providing observability as a service to your users so that they can use things like OpenTelemetry for their workloads. So in that latter example, then yeah, observability is a product. But as a platform owner and a platform builder, I believe we should treat observability as a first class citizen and part of MVP. It shouldn't be an add on later, it shouldn't be an afterthought. To answer your question more directly about the platforms I've been involved in building in, there's a variety of maturity there. Part of that is things like building the platform before OpenTelemetry existed. And so it was never going to be an original first class citizen. And we've done a lot of work to retrospectively create it as a first class citizen. But that's non trivial when you've got people that then need to migrate from whatever they were using previously. Enterprises, particularly, have often got long tenures because they're larger organizations. And so they might have pre existing relationships with other monitoring tools or vendors. And then you've got to encourage them to move from something they're very familiar and comfortable with towards using OpenTelemetry. And that becomes that tension again between standardizing on a single product or tool versus having the uniqueness and the endless customizability that people like to have. The reason I choose the word monitoring tool is really deliberate. So I think you and I have discussed this in person around, I really like Charity Major's definition of monitoring versus observability. I'm probably going to butcher this, but I'll give it a go. The TLDR is that monitoring is the known unknowns. So to create something that's going to monitor that or surface your metric, you know what you're looking for and you know what good looks like. Whereas observability is really trying to address the full end-to-end picture of how everything behaves. And in such, what you're really looking for are the unknown unknowns. So if you don't have that telemetry as a first-class citizen, you're not going to be sure if you have something unusual or unexpected happening under the hood.
Yeah, exactly. Yeah, the unknown unknowns. But how does that then look from the perspective of your developers in the platform that you operate today? Is how do they can they? I think one of the sort of the part of this definition is that you should be able to ask questions about your system, right? Because that's how you can ask these questions that you don't know about beforehand. So how is that basically that developer experience created that you as a developer create a new service, you deploy it into production? Can you tell me a little bit more about how that journey looks like from a developer perspective?
To start with, I actually think for us it didn't look great, but we didn't know it didn't look great until a couple of applications had some challenges. And so the questions that you've just alluded to came at the time of an incident or came at the time of a pre-production run and someone said, "Oh, that doesn't look quite like we were expecting." And so the teams that had the best experience had already shifted left very aggressively and we're leaning on lots of those long-standing best practices around all the different kinds of testing. So not just having unit tests, not just having integration tests, not just having smoke tests, having like a full test suite so that you know when something isn't behaving as expected. That said, that kind of monitoring doesn't provide you the answer to the question that you might be asking in terms of the unknown unknowns. So I don't think we got this right out of the box. In terms of what we've learned and how we've developed that, I think there's two angles to consider. One is the education piece and actually talking to people about how to use the platform best. You can't assume that if they're migrating from a different set of tools to open telemetry that they necessarily even know how to build their systems. That's an unfair expectation in my opinion. And similarly, it's also about how we build the platform to make sure that we have monitoring of the platform that is visible such that teams know if we're the ones creating the problem. I'm not going to say at fault, creating the problem versus if it's behavior in the application themselves, or typically where it gets harder to diagnose is when it's the interaction between a marketplace service and the application. And in particular, if you get people on an instant call, where I believe that providing observability as a service is really useful, is twofold. It neutralizes the emotional tension because it's essentially an unbiased non-human observer, but also it helps you explain the black box, perhaps, of your processes while also understanding the black box of their processes. Because often in a regulated industry, so we're FCA regulated as an example, as many banks should be, you can't see the application code, and I wouldn't be at liberty to go in and make any changes to experiment. So I can't necessarily recreate the issue that we've seen. And so the telemetry logs, be that metrics or whatever else that you're using, is the only thing that can tell you the picture neutrally of what's occurred.
Interesting. Yeah, that actually sounds a little bit like an interesting segue into sort of my next topic, because this black box is also what we experience a little bit with AI, right? And with AI, we also start to ask questions in a natural language, like starting to ask questions about our systems. But before we maybe get into that discussion, maybe we can just quickly like talk a little bit about what AI means for platform engineering in general. What's your opinion on this? Is the platform engineering an enabler for successful adoption of AI, or how do you sort of see this?
So my gut instinct when AI really started becoming more agentic, so autonomous without human oversight, my gut response was surely platforms are an enabler because they allow you to have centralized governance or policy and hopefully observability if you've treated that as a first class citizen. That said, as someone that has a scientific background, I should highlight I've worked in platform engineering for over a decade, so I'm largely very biased. But the other angle to look at is cognitive load. AI is moving so fast. If you think about the cognitive load of all of the rest of the changes that we've seen over the last 50 years, this is happening in such a compressed fashion that if platform engineering, one of its key tenets was to improve developer experience by lowering cognitive load, that can only be of benefit to the human users. But equally, if you think about context windows and the behavior of LLMs once they get too full, again, if the platform can reduce the cognitive load for the agent by providing curated context, I think that's also going to be a huge advantage. And I really like the work that Patrick Dubois has been promoting through Tessel on context driven development. And that's certainly the way I'm leaning as opposed to something like spec driven development. I think that created context and providing MCPs with all the best practices that we did for APIs is probably more likely to be successful for platforms.
Yeah, so AI will lower the cognitive load for developers, but what about platform engineers? What how does their sort of cognitive load curve look in this new
Yeah.
world?
I mean, it's slightly egregious to quote myself, but I did do a keynote at Fastflow last year called The Conservation of Cognitive Load. And what I was trying to surface through some GCSE physics references is that the platform team ends up absorbing lots of that cognitive load. And so my advice or warning or I guess theory here was that to do a platform well, you needed to make very conscious decisions about what cognitive load to absorb in the platform versus what cognitive load to keep with the developers. And I typically use the rubric of, well, who's the domain expert? If this is something that is standardized or central and is in the wheelhouse of infrastructure or DevOps, it naturally sits in the platform. If it's specific to one individual app and no other user will benefit for it, that cognitive load probably should stay with the application.
How do you see this then evolving over the next, I don't know, months, years in terms of the software delivery life cycle in general? Where are we in, let's say, 6 months, a year from now?
I'm very hesitant to make really concrete predictions because so many things have changed. I think it would be unwise to say with any certainty what a non-deterministic system is going to look like. But I will say there are some extrapolations that we can make with some confidence that they're at least worth testing. So I'm biased. I live in an echo chamber of people like yourself, but I think we have started to agree that coding was never the bottleneck. I think a lot of us felt this anyway, right? And my concern with people talking very specifically about spec driven development is that people forget that agile was trying to minimize the impacts that humans aren't good at knowing what they don't know. And things change. Even if your architecture is perfect in 2020, it may not be fit for purpose in 2023. And so, this utopia, if we just try harder to write a spec, everything will flow from there, is probably a little bit hopeful and naive. Context driven development in a reductive way here is basically about providing the agent everything it needs to make the decisions. And from my own experimentations and some of the literature, but again, possible echo chamber, shows that providing good context is what allows the agents to make their own decisions best, and you see better behavior from doing that. So if you take the utopia as a dark factory and whether or not we have the trust in that dark factory, observability is going to become a really key component. And I think it was Liz Fong Jones that was talking about how a lot of what used to happen in pre-production probably now happens in prod, which feels very uncomfortable. It doesn't sound very purist. And looking at things like continuous evals and live fixes where agents autonomously are updating their own workflows through continuous loops is something I think is really interesting. One thing I will say, and I don't know if this will be controversial, so forgive me if it is. When I watch a lot of the presentations from people who sit on the side of building the LLMs or building the harnesses for people like me to consume, a lot of what they're saying feels like we're actually just going back to first principles. So part of it's like, well, of course. So to give you an example, if you think about the learning of how Anthropic, as an example, explains how they came to come to dreaming, where you consolidate all of the outputs from your agents at the end of the day, much like a human does, where it looks at all the different memories from the day and decides what to transfer to long-term memory. The way that looks at the back end is treating everything as a file and putting it into a file system. And file systems are something that we understand really well. So I think the winners in this space will be the engineers who are able to dissect from a novel new experience those first principles that are still valid and endeavor where possible to do the simplest possible architecture, because models change so frequently. If you make any of your harness too specific to that model, you're going to be rebuilding it over and over again.
Yeah, exactly. But I just want to like get your take on what worries you the most then with this development that we are seeing right now.
So, something I think isn't well understood, and we might only learn this with time, is the impact to people. And I'm specifically thinking here, just as one example, around what it means for raising the next generation of engineers. Senior engineers aren't born. I certainly wasn't. I made lots of mistakes in my career. So, on the positive side, AI gives you access to so much more than you ever did by just reading textbooks. And if you're thoughtful in your approach to using AI, I think you can learn and ramp up really quickly. However, I don't think it necessarily gives you that same homegrown experience of testing your cognitive capacity for critical thinking. And because of the slightly sycophantic nature of LLMs, it's very easy to think, oh, this was obvious, without thinking about the edge cases. So, as promised, back to my code red moment. Where we went wrong is that we didn't think about enough edge cases and we didn't consider an unknown unknown. And so if we had been designing that system with an LLM, we also might have been encouraged to think of even fewer edge cases that might have led to an outage.
Yeah, it is an interesting world we are heading into, and it's definitely gonna be hard to figure out a good way to give that same experience to junior engineers entering the job market today. That's definitely gonna be a challenge. So to close things out, if listeners take away one idea from this conversation about platform engineering, AI, observability, what would you want it to be?
I think it would be some passing advice that I've been giving to mentees recently to stay curious and to be open to questioning any of the paradigms that you hold as fact might look different in the new world. And in science, when you have a hypothesis, the idea of running the experiment is never to prove the hypothesis, it's to look for ways to disprove it. So I would encourage you to stay curious, do lots of experiments to learn for yourself, but also ask yourself, does this still hold true in the new world?
That's good advice. Thank you, Rachel, for joining me on Code Red. This has been a really interesting conversation.
Lovely to see you, Casper.
This was a fascinating conversation, and I think listeners will walk away with a much clearer understanding of why platform engineering, observability, and AI aren't separate conversations at all. They are increasingly becoming the same conversation. For those listening, we'll include links to the resources we discussed in the episode description. Thanks again for tuning in. I'm Kasper Borg Nissen, and we'll see you in the next episode.